All right, Gary. I explained my position and attitude in the last video. If you want to change that, it has to be bilateral. And I'm not thinking that's happening. Obviously, I'm probably not going to get through 3 hours of this. Hopefully not, because it's already almost 2 o'clock. But I'm feeling pretty good because I got something working. An API package that I've been making to use for another project in my work, by which I mean the paying kind, as opposed to the tremendous amount of work I do that doesn't pay, at least not directly or perceptibly. That's not the subject. How did I get on that? No, we're going to watch Mr. in Mendham. Probably not 3 hours worth. God only knows. Let's see. Do I have it at a high speed? Yeah, double. How much? How much can I take? It's also late, so maybe I'll stop because of the time, not because Gary is rude. Maybe he won't be rude. He was, I don't know if rude is the right word for the first 10 minutes that I watched earlier, but anyway, let's not waste any time, really.
Of the mathematics. And again, I'm going to be using the same variables because the variables are important. The frequency of the light is important. We know that. Electrons move a different distance based on what frequency light hit them. This is already known. It's essentially a pressure imposed on the electron. So this isn't complicated. There's no math.
It's already known. Well, a lot of things are already known that you don't believe, right? Other people think they're known and you don't believe them, but you just pick and choose which are obviously known. It's not going well.
Math in conflict here. We're not arguing about a mathematical description. We're not arguing about a mathematical model because the math doesn't say anything about these models.
Yes, it does. That's ridiculous. The math says exactly how the number to the left and to the right relate to each other.
There is no math for single slit interference unless you inject the Huygens.
What do you mean inject? That is the basis for the math. And there's other Maxwell's equations and stuff when you get to how there's no math unless you use the math that was presented by a guy. Yes. And that is the math. And if you do that math, you do get the answer for the diffraction with a single slit. You do get the diffraction between two slits and their interference. And you can... Oh,
All right, so I want to point out another thing on this whole idea of doing different experiments with different objects. And just for the record, I'll just say that now they're going to claim that these are real manifestations of the interference, a wave interference pattern. So they take molecules, a clump of molecules, 100 atoms, and they throw it through the slits. And they're arguing that there's a wave interference pattern that creates a pattern at the end. So somehow throwing 100 atoms manifests some sort of wave property. The wave property interferes with itself, and then it tells the hunk of matter where to land. So I'm going to argue that that's a theory based on the fact that apparently these 100 atoms don't know where they are, so they first Heisenberg. All right, I'm going to argue that none of that's true. That if they put detectors on the slits now they're throwing things this big, they certainly can throw photons at them without disrupting them too much. And I'm sure they can figure out what slit they went through. So now we can resolve this whole double slit, which slit did it go through thing, and find out that there's no necessity for it to go through both slits. And we'll find out what slit the things go through and where they end up. And we'll find out that the pattern isn't destroyed by knowing what slit it went through. So we can end some of this nonsense.
Well, that's what you bet, but I don't know if they've done that particular version of the experiment, but they've done other similar things, like photons can go through crystals, and you can tell because of a slight voltage change in the crystal, and you add a little bit of power so it doesn't take power out of the photon, and you can tell, and then it disappears. So maybe it would turn out the way you think, but the fact that you think your intuition is for sure going to be right in the way an experiment turns out shows you don't have a scientific attitude.
But again, how exactly is this wave being manifest in a 100 atoms? So they're saying a thing with 100 atoms still possesses some sort of wave property, that it has a frequency. A single clump has a
It's important. The evidence for that is that if you shoot it through the slit, there's the dark interference patterns from the negative interference, the destructive interference, which is the part that doesn't happen with bullets. You can't shoot a bullet at a frequency with the second bullet such that the first bullet never hits the target. But that's what we see happen. Dark spots where the photons don't even hit the target, even though you're shooting them one at a time. Somehow there's an interference pattern.
frequency. That's what they're saying. Does that make sense to you?
Yes.
Yeah, well, what more do you need? Because it's dependent on the wavelength, mass, and everything else.
Right, the wavelength, again, just recognize, these are things that don't have, these aren't like photons. They're not wavelength dependent. Electrons don't have a wavelength. And they're not sending
Okay, according to the standard model, they do. You are disagreeing with that. Fine. Stop saying it doesn't exist. According to the standard model, according to what I happen to believe, and by the standard model, don't be confused, audience. It's not standard, standard, standard. That's what it's called because in physics it has been adopted so widely they call it the standard model. And then superstring theory and supersymmetry, or string theory rather, and supersymmetry, those are extra theories. They're related, they're supposedly compatible, but that's different. The standard model is just the basics, which now with the LHC, every particle predicted in there, which includes antimatter, impressive prediction, includes the Higgs boson, impressive prediction. But supersymmetry, no. Its predictions don't seems to have failed. It predicted things that should have been seen now. Okay, back to Gary.
electrons through at a frequency. They're just sending them through. So they're not sending like a clump and then a clump and then a clump and then a clump of electrons. They're just sending electrons, and they're saying we're going to, just to fit the math, we're going to make F equal, mass or velocity equal frequency. So we're going to force them to have a frequency just because they're.
That's not true at all. That's not at all. That's not what they're doing.
Moving. It's almost like saying, if I walk over to pet the cat.
You see, frequency doesn't mean how often you shoot a photon or a ton or anything in wave mechanics. The wave is like this, right? And the frequency is how far apart in time, which relates to distance, are the peaks. The repeating pattern of a wave. A wave pulse, it's nothing and then boom and then goes back to nothing. So you don't think that, but do you understand that that's the basic idea? That's the idea I have that I'm presenting, but also it's not like I don't want anybody to get the idea. I invented it. The position of the quantum mechanics in the standard model and QED is that mass does also have a wavelength. And when you diffract it, or you double diffract it with extra interference, when you see those dark bands, that is a pattern you don't see with bullets. You can't subtract. One bullet can't subtract the other bullet. But waves, that can happen. So it's a way to tell the difference between the two types of phenomena. And it turns out that so far it's been seen in photons. That's no surprise because they looked wave-like for a long time. Not back with Newton. There it was still a debate. But later on, when it showed diffraction and the interference lines in the double slit, oh, it's obviously a wave. But then it showed particle behavior as well. That's the quantum odd part.
I'll have a frequency.
So, and the width of the slit. So that's right. The fact that you see the two little humps, as long as your detector can handle how delicate the measurement is.
Oh yeah, and then the other odd part is the things that seemed obviously particles, like electrons and protons and neutrons, they show wavelength phenomena, the diffraction and interference patterns.
So he's talking again like this is more delicate. These are bigger things. The detecting is the easy part now because they've gotten so big. You're almost to the point where you can take a slow motion camera and a strobe light and actually watch them fly through the slit.
Then you can see the effect.
You can't watch them go through. That's the whole thing why they say that if you observe them. But it's not that you observe them, it's that if you touch them at all, it's like they're committed to that particular path. If you don't, then it doesn't matter which way they went, as long as they could end up in the end point location. I'm sorry, that's how it looks. I'm sure there's a more sensible way of putting it in the future when we advance our ability to picture it. If only someone would come up with some way to visualize the way things really are in a more sensical way without, like you, falsifying the way things are. I'm almost done.
If you have a low resolution camera, you won't see it. Surprise!
Right, so again, what does this have to do with the fact that the photons are the smallest resolution object, and you get the most definition in the pattern? So it's quite obvious if you wanted to study the pattern, the thing to study it with is the high resolution image, not the low resolution image. I'm just saying.
For the millionth time, it's because photons look wave-like at macroscopic levels. Prisms, for example. Whereas electrons and neutrons look like little particles, like BBs, like bullets. And more or less, that's their main characteristic. But when you look carefully, you can see the particle, bullet-like aspect also applying to photons. And, perhaps more surprisingly, the wave-like phenomena of diffraction and interference in the electrons and the neutrons. That's why, for the millionth fucking time, it's of interest to do more than one particle type.
If I logically cared about pursuing the answer to why the phenomenon happens, I would obviously choose to play with the thing where I get the most resolution.
It could be anything if you don't do the math.
Right, well, so okay, so if you don't do the math, right? So he's saying there's logical math where you take the frequency of an object that doesn't have a frequency, just a speed.
No, but we think, no, in our system where we use the frequency, it does have a frequency. You're simply saying it doesn't have a frequency. But to consider our system, you would have to say, okay, well, if it has a frequency, then you do this, and you do this, and you do this, and how does it turn out?
And you say, okay, we're going to call it speed, now a frequency, and then how much it's deflected, and these are nuclear bits.
We're not calling a speed. See, all light goes the speed of light, but the frequency changes. When you have mass that doesn't all go the same speed, then its wavelength is based on its momentum, which is based on its relative speed. Now, relative to itself, what's its speed? Fuck.
This is the truth. Slow motion camera and a strobe light and actually watch them fly through the slit.
Deja
You can see
vu.
the effect. If you have a low resolution camera, you won't see it. Surprise!
Right, so again, what does this have to do? Maybe, okay, it's a phenomenon being created by same functions. It has to be a wave somehow because of the pattern. It can't be explained by anything else, ever. No way, you're not even allowed to think it. It's really this is just that bad.
When did I ever, hey, change your diapers. When did I ever say, you can't think it, you can't say what you want to say? When in the dozens, if not hundreds of hours that I've answered you on this and other topics, did I say, you can't think what you said? You're not allowed. Never. Do you think it's okay to be hysterical like this? This doesn't count as a lie to you? That you're hysterical about this kind of thing, the way you're putting it this way, when I have never, ever, ever in any ever of our many years, decade of conversation, said, you can't think that, you can't propose that. I've never said that. I just said what you're proposing is Crazy. Totally different comment.
Just thought. You're just not allowed. The Inquisitioners are coming for you, and they will insult
You are allowed to be crazy. In this way, I don't see how this is harmful. Anybody that believes the shit you're saying is already batshit crazy. Obviously, they obviously have less of a clue than what you have to offer. It's not really harmful in that respect. So go for it. Be crazy. I'm not saying you can't be, but I'm also saying that, to be honest, I have to admit, this is crazy shit you're talking, and the way you're talking and presenting it, and the hypocrisy of wanting to be validated for your hard work, but you won't even say, hey, thanks for talking to me about it. You know? Okay, go on.
your character, lie about what you've said, because they got to protect their god, the wave.
with the mathematics.
I'd like you to answer if waves, you just think waves are imaginary. They're crazy talk. Great waves. I've never seen a wave. What? Because it's kind of extreme, your anti-wave shit. Why couldn't light be a wave going through a medium? Why not? How is that magic? Like a wave going through the ocean, not magic, so they thought, hey, a wave going through some other kind of medium, not magic.
That's an important part of it. Saying
Again, it's not an important part of this. We're explaining why it's happening, not the fact that it is happening. The math is just a representation of the pattern. It's not explaining how the pattern gets there.
mathematics
It has some implication on that.
is important. I'm going all from my eyeballs.
I mean, like Huygens is saying that every part of the wavefront's coming along. You've seen that. And as it's coming along, you can notice that the little drops of water in that water are going up and down. That's why it's rising up, right? And that's water that was already there going, up and down. And the wave passes through, right? It's going up, it's going down. That's a real phenomena, right? The water is actually moving up and down. The wave is going through it. Why couldn't light be a wave going through some medium? That's a perfectly sensible idea, especially after it starts to show wave-like mathematical characteristics. It's not a lie to think that might be related.
My intuition.
Again, so this is the lie part, right? Where have I ever said the math isn't important at all? No, I mean, the equations
You just said it a couple minutes ago.
are the equations. It's okay with me to have defined proportional relationships between frequency, the width of the slit, and the pattern. Those relationships are real. The question is what's causing the relationship. And my explanation is different than yours. My explanation is it's a consequence of the relationship between any of these items and crashing into electrons that exist between the slits. Narrow
See, that's an okay way of putting it.
slits create electron density. That's what happens when you take two material things and put them close to each other. The electrons spread between the distance.
We're at a level higher than the higher.
I just can't believe that you think you can intuit this kind of stuff. You rejected all the science more and more every day as you research more of it. You reject, and then just say how it really is in contradiction to the people that have done experiments. You're not even reserving opinion. You're saying how it actually is, rejecting experiments, in which case you have to call experimenters all liars. And I just didn't think that your mental state was that extreme. I didn't think you were one of these guys that, but thinking back on it, I see how it has always been that way in every subject. And yet it's your willingness to have an elastic collision with any opposing idea, shoot off over here, not be affected, not inelastic, not let's find out what's going on, but rather, fuck you, Tard, no, I'm too cool, what are you talking about, green versus blue? And you kind of do, you do that in every subject. Sometimes I hate learning new things.